Part 20, Rational Numbers and Irrational Numbers. You will find this on page 48 in the Namibian Mathematics Grade 8 textbook, Y equals mx plus c to success. There are many different types of numbers, and up to now we have learned about some of them, such as natural numbers, whole numbers, integers, and fractions. These are called rational numbers. A rational number is a number that we can write as a fraction, meaning a over b, where a and b are both integers, but b can just not be 0, because I cannot divide by 0, it's undefined. Integers and common fractions such as 12, negative 11, 2 over 3, negative 9 over 4 are all rational. However, only some of the decimals are rational. There are 3 types of decimal fractions. Terminating decimals such as 0.625, 0.9, 3.8375. They end, they stop. It stop after the 5, it stop after the 9, it stop after that 5. Then recurring decimals such as 0.333, the 3 recur. Then 2.151515, the 15 goes on. They repeat forever and ever. And then infinite or non-recurring decimals such as 3.1419325, and it just go on. They never end and never repeat decimals. Only the terminating and recurring decimals are rational numbers because they can be written as common fractions. Like 0.625, you can just say 6 to 5 over 1,000, simplify it to 5 over 8. 0.9, which is 9 over 10. 3.8375, you can say 8375 over 10,000, and it will simplify to 3 and 67 over 80. 0.333, it's 1 over 3. You can test it on the calculator. 2.151515, it's 2 and 5 over 33. Test it on the calculator. Now, I think this one we already mentioned there. Now, the infinite non-recurring decimals are irrational numbers because they do not come from common fractions and they cannot be changed into common fractions. Irrational means non-rational, like square root 2, which is 1.141213562, just going on. Square root 6, 2.449489743, and just going on. The cube root of 50, 2.466212074. So most of the roots will be irrational, but not all of them. Because if you have, for example, square root 16, it's an answer of 4. But irrational numbers will be mostly in root form, and then it will give you irrational numbers. An irrational number is a number that cannot be written as a fraction. Okay, let's continue to the next page. Here is just a summary. So rational numbers, remember, we can write it as an integer over an integer. Whereby irrational numbers, it's usually underneath a root, and we cannot write it as an integer over an integer. Now pi, the symbol for pi, the ratio of the circumference of the diameter of a circle, you will work with this value when you work out the area and the circumference of a circle, is a famous irrational number. People have calculated pi to over quadrillion decimal places, and still there is no pattern. The first few digits look like this. Look, I wrote it down. But you can go to the internet and you will see nice displays, even posters, of this decimal places that is just going on and on and on. The approximations of 22 over 7 or 3.14 are just to help you to make calculations easier, but they are not accurate, and these approximations are rational numbers. So the symbol is irrational, but these approximations, they are rational numbers. I want you to do class activity 4. Stop the video, and as soon as you are finished, you can continue with the video. Okay, let's start. I'm asking you, use a calculator to evaluate each of the following numbers as decimals. It always helps if you use a calculator. So this is negative 2.25 and it stops there. Okay, let's look at number B. It's 2 over 3. So this will actually be 0.66666. Now to indicate that, I'm going to make a point there. So that 6 is continuing. Then number C, it's 1 over square root 2. Okay, a few digits is 0.707106781 and it continue. And then number D, which is 5 over 6. Again, it's 0.8 and then 3. So let's just write it like this. Then we know it's the 3 that continues. And then number E, it's 2 and 1 over 8. This is a nice one. It's 2,125. Okay, number F. I think you will struggle with a normal calculator to see the pattern. But try to press it in on the internet on something that you can see because there is a pattern. It's actually 3,142, 142,857, 857. And then it continues, 142,857. So basically that part continues. Okay. And then number G, negative 3 and 7 over 11. That will give you negative 3.6363. So this continue, and I'm just going to write it like this. Just remember this one also continue. And then number H, it's 25, the cube root, not square root. And that will be 2.92401778, and it just go on. Okay. And then number I was 64, easy one, so it stops, it's just 8. And then number J, remember pi, and it's actually just 3,141,592. Okay, 592,654,654, and remember it's continuing. Okay, now state which numbers in question 1 can be written as terminating decimals. That means decimals that stop. Okay, now let's look at number, let's just get a pen. Let's look at number 28. Terminating decimals, it stops. Oh, there's a nice one. Can you see? So it's negative 9 over 4. Let's see if we find another one that stops. Oh, here it will be. So it's 2 and 1 over 8. And then this one also stops. So it's 64. Okay, now number B. Recurring decimals. It's this ones with the dots. Can you remember? So it was 2 over 3. It was 5 over 6. And then there's another one. Oh, I skipped this one, which was a bit difficult to see, which was 22 over 7. And then the last one is negative 3 and 7 over 11. That's all continuing. Okay, let's see if I marked all of them. Yes. Okay, let's go to number 3. Let's get another color. State which numbers in question 1 can be written as infinite non-recurring decimals. That means that's decimals that's just going on. Look there. So it will be 1 and square root 2. Okay. Let's see if we find another one. I'm looking for the ones that's not marked. Do you see this one? It's the cube root of 25. Oh, and don't forget that famous pi. Okay. And now, are the numbers in question 2 rational or irrational numbers? Now look at the blue. If you look there, let's just write it as number 4. Now, if you see, it's a fraction, a fraction, a fraction. All of them are fractions, and even this is 8, which can be written as 8/1. So they are all rational numbers. Because they can be written as, okay, let's just write it nice. So we can say they are all rational numbers. All the numbers are written as a fraction A/B, where A and B are integers. You can write something like that. And then, number 5, are the numbers in question 3 rational or irrational? What will they be? They will be irrational. And why? All of them are irrational. They are irrational because they cannot be written as a fraction A/B, where A and B are integers. You can just finish off with that.